February 20, 1943, north of Kasserine Pass, Tunisia. Official combat summaries would never truly explain what German armored officers saw unfold that day. Across the dust-choked battlefield of North Africa, American Sherman tanks carried out movements that seemed to violate every principle embedded in Wehrmacht doctrine. 5 Shermans, divided by rocky terrain and completely out of visual contact with one another, advanced on German positions with uncanny precision. No signal flags waved through the haze. No flare pistols flashed. No couriers sped between vehicles carrying instructions. Yet the tanks maneuvered with the unity of a single living machine, each one instinctively shielding sectors the others could not observe. Every crew somehow knew the exact position of its companions. Inside German Panzer IVs fitted with FUG-5 radios, commanders fought to hear even their own officers through storms of static drowning their amplitude-modulated systems. Germany's 10-watt transmitters, considered advanced during the 1930s, often failed beyond a few hundred meters once tanks began moving. Most German vehicles carried receivers only, leaving crews unable to transmit sightings, request support, or report danger. The Americans, meanwhile, were fighting with equipment the Germans scarcely understood existed. Every Sherman carried frequency-modulated radios using crystal-controlled precision, broadcasting at 25 watts with voice clarity that sliced through engine roar and battlefield chaos effortlessly. Nearly 8,000 kilometers from the assembly plants of Detroit, the most important technological edge of the Second World War was beginning to reveal itself. It had nothing to do with thicker armor or larger guns. It existed instead in invisible electromagnetic signals linking American tank crews into a unified battlefield system unlike anything the Wehrmacht had imagined. The transformation had officially begun on July 22, 1941, when the United States Army standardized the SCR-508, SCR-528, and SCR-538 signal corps radio sets for all medium tanks. While German armies surged across the Soviet Union using tactics dependent upon communication between command vehicles, engineers at the Galvin Manufacturing Corporation, later renamed Motorola, were refining FM technology that would ultimately leave German radio systems obsolete. Among the engineers were Daniel E. Noble, who envisioned applying FM technology to armored warfare, and Chief RF engineer Henryk Magnowski, who solved the immense technical problems of fitting sophisticated electronics into combat vehicles enduring heat, vibration, dust, and shock. Their creation weighed 181 pounds and effectively transformed every Sherman tank into a connected node within history's first true battlefield communications network. The BC-604 transmitter produced 25 watts of power, more than double the output of Germany's FUG-5 systems. Operating between 20.0 and 27.9 MHz, it offered 10 preset channels stabilized through crystal control. The SCR-508's paired BC-603 receivers allowed commanders to monitor multiple frequencies simultaneously, an ability that would become devastatingly effective in combat conditions. Yet the true revolution was frequency modulation itself. Edwin Armstrong's FM technology, licensed for military use, eliminated the interference and static that constantly crippled amplitude modulation systems. German radios captured every electrical surge and mechanical spark as noise. American FM equipment, by contrast, delivered clean voice communication even during artillery bombardments. November 8, 1942. During Operation Torch, American armored forces landed in North Africa carrying SCR-508 radios that would soon demonstrate overwhelming superiority over German battlefield communications. The Afrika Korps, despite being Germany's most battle-hardened armored force, suffered from crippling communication limitations. In a typical German platoon of 5 tanks, only 1 or 2 vehicles possessed full FUG-5 transceivers capable of transmitting and receiving. The remaining tanks carried only FUG-2 receivers. They could hear commands but had no ability to answer or relay information. German armored doctrine depended on rigid hierarchy. Platoon leaders issued orders while subordinate tanks acknowledged instructions through movement rather than speech. Once command vehicles, easily identified by their multiple antennas, were destroyed, entire platoons frequently collapsed into confusion. Against American units where every Sherman could assume command functions, this weakness became catastrophic. The Battle of Kasserine Pass, fought between February 14 and 24, 1943, marked the first major demonstration of American communication superiority. Although the engagement ended as a tactical German victory, Wehrmacht observers were stunned by what they witnessed. Amid the disorder of the fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across nearly 50 miles of battlefield. Tank crews who had never previously met synchronized attacks, warned one another of threats, and summoned artillery support through crystal-clear FM communication. German signals intelligence operators intercepted American transmissions and noted both their clarity and coordination. Intelligence officers from the 10th Panzer Division reported that American units maintained effective communication at distances where German radios produced only static. Even more alarming was the realization that every American tank appeared capable of transmitting, not merely command vehicles. German FUG-5 radios, operating on amplitude modulation between 27.0 and 33.3 MHz, suffered from severe technical limitations. Their 10-watt transmitters reached only 2 to 3 kilometers under ideal conditions and often deteriorated to a few hundred meters while moving. Every spark plug ignition, electric motor, or grinding tank track created interference that AM technology could not suppress. September 1943 brought American armored forces into Italy, where mountainous terrain should theoretically have erased any radio advantage. Instead, FM systems became even more valuable. The SCR-508 handled the signal distortion and multipath interference of mountain valleys far better than German AM equipment. American tanks coordinated maneuvers through terrain where visual signaling was impossible, and German communications repeatedly failed during the advance toward Cassino. American armored units displayed capabilities that baffled German observers. Tank platoons separated by ridgelines executed coordinated attacks with precision that German doctrine insisted required direct visual contact. After-action reports from the 1st Armored Division described routine coordination at distances where German radios produced nothing but noise. June 6, 1944. As Sherman tanks rolled down landing craft ramps onto the beaches of Normandy, their SCR-508 radios maintained direct coordination with naval gunfire support, something impossible using German communication systems. Yet the brutal hedgerow fighting soon exposed a dangerous flaw. Tank radios could not communicate directly with infantry radios operating on entirely different frequencies. Infantry SCR-300 radios functioned between 40.0 and 48.0 MHz, incompatible with the tank radio spectrum of 20.0 to 27.9 MHz. This communication gap proved deadly inside the Bocage country, where German infantry armed with Panzerfausts could stalk American tanks while nearby American infantry had no reliable way to warn them. American crews improvised a solution within weeks. EE-8 field telephones were mounted inside ammunition boxes welded onto the rear hulls of Sherman tanks and wired directly into internal communication systems. By the time Operation Cobra began in late July, this simple innovation had transformed tank infantry cooperation. July 25 to 30, 1944. Operation Cobra demonstrated the full destructive potential of American communication superiority. Major General Edward H. Brooks' 2nd Armored Division coordinated more than 200 Sherman tanks through radio networks that allowed a degree of battlefield control unprecedented in armored warfare. German defenders from the Panzer Lehr Division confronted an enemy that appeared almost supernatural. American tanks reacted instantly to threats reported by units miles away. Artillery fire missions coordinated through radio networks struck targets within minutes of identification. The contrast with German capabilities had become devastating. Panzer Lehr, once among Germany's elite armored formations, now operated under communication collapse. Most tanks fought without functioning radios, relying on visual signals in terrain where visibility often fell below 100 meters. The few working sets suffered interference and short range that made effective coordination nearly impossible. The irony was striking. Germany itself had pioneered radio use in armored warfare. Heinz Guderian, architect of Blitzkrieg doctrine, had demanded radios in tanks since the 1920s. His 1937 work Achtung Panzer emphasized communication as essential to armored operations. Guderian understood that rapid mechanized warfare depended on reliable coordination. Yet by 1943, German industry could no longer produce radios in the quantities demanded by Guderian's own doctrine. Production statistics revealed the scale of the crisis. During 1943, Germany manufactured roughly 5,700 medium tanks but produced fewer than 2,000 FUG transceivers. Many of those radios were reserved for command tanks and assault guns, leaving ordinary armored units desperately short of communication equipment. Soviet armored forces faced even worse conditions. The T-34, despite becoming the most heavily produced Allied tank, often entered combat entirely without radios. Soviet doctrine relied on flags and prearranged battle plans, a weakness that proved disastrous against German forces in 1941. By 1943, Lend-Lease aid provided partial relief. American radios, including SCR-508 sets, equipped Soviet command tanks, but even by war's end only around 1/4 of Soviet tanks carried radios at all. The comparison highlighted the magnitude of the American achievement. While the Soviet Union struggled to equip 25% of its tanks with basic radios, the United States achieved complete deployment of advanced FM communication systems. Motorola's Chicago factory became one of the greatest symbols of American industrial mobilization. Before the war, the company produced car radios. Transitioning to military manufacturing required complete retooling and the solution of unprecedented engineering problems. Every SCR-508 contained 2,748 individual components manufactured to exact tolerances. The BC-604 transmitter alone required 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite violent vibration and extreme temperatures. Production numbers reflected American industrial power. In 1942, factories produced 3,800 SCR-508 family radios. In 1943, production rose to 11,400 units. By 1944, output reached 24,000 systems. Total wartime production exceeded 50,000 tank radio sets. This manufacturing miracle ensured that all 49,324 Sherman tanks built during the war received sophisticated communication equipment, an accomplishment unmatched by any other nation. The SCR-508's advantages extended far beyond FM clarity. Crystal-controlled stability allowed tanks to preset channels before battle and maintain precise frequency alignment under combat conditions. German FUG-5 systems, dependent upon variable capacitor tuning, constantly drifted off frequency. The dual receiver arrangement enabled commanders to monitor platoon and company networks simultaneously. Orders moved instantly down the chain of command while commanders retained continuous awareness of subordinate units. The BC-606 intercom integrated perfectly with the radio system, allowing every crew member to warn the commander about threats. Noise-canceling headsets and throat microphones enabled clear speech during battle. Many German tanks lacked intercom systems entirely, forcing crews to rely on shouting or physical gestures. Power management offered another major advantage. The SCR-508 could function on either 12 or 24 volts, automatically adapting to available power sources. Its dynamotor supply generated stable filtered current that eliminated electrical interference. German systems, drawing directly from vehicle electrical circuits, absorbed every spark and surge as static. Universal radio deployment fundamentally transformed American armored doctrine. Flexible combat command structures, temporary task forces assembled for specific operations, depended entirely upon reliable communication. American commanders could rapidly combine units from different formations knowing they could coordinate through standardized radios. German commanders, trapped within rigid organizational structures created by limited communications, found this flexibility incomprehensible. During the Battle of Aricourt in September 1944, the U.S. 4th Armored Division faced German panzer brigades equipped with superior Panther tanks. The Germans held clear advantages in armor protection and firepower, yet American radio coordination proved decisive. Every Sherman could instantly report enemy sightings. Tank destroyers received targeting data from vehicles they could not even see. Artillery observers riding in Sherman command tanks called devastating barrages within minutes. Across 3 weeks of combat, the 4th Armor destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 ratio that completely contradicted technical comparisons on paper. Throughout the war, German intelligence never fully grasped the importance of American communication superiority. Reports repeatedly mentioned American coordination yet attributed it to training instead of technology. One captured German intelligence assessment from September 1944 stated, "American tank units demonstrate strong radio discipline and coordination." This appears to result from extensive training and rigid communication procedures. The report entirely overlooked the true technological advantage. German tactics never adapted to American capabilities. They continued targeting apparent command tanks identified by antenna arrangements, unaware that every Sherman could coordinate battlefield operations. They prepared ambushes assuming American tanks would lose cohesion once separated visually, never realizing radio communication preserved unit coordination regardless of terrain. March 1945. As American forces approached the Rhine, their communication dominance reached its peak. The seizure of the Remagen Bridge demonstrated the astonishing speed of American command systems. When elements of the 9th Armored Division discovered the Ludendorff Bridge still standing, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the front had begun shifting to exploit the breakthrough. German units, dependent upon telephone networks systematically destroyed by Allied aircraft, could not respond with comparable speed. American radio coordination transformed the bridgehead into an impregnable defense. Tank platoons from separate battalions integrated seamlessly through radio networks. German counterattacks, crippled by communication failures, arrived piecemeal and were annihilated individually. April 1945. The encirclement of the Ruhr Pocket represented the final culmination of American communication superiority. Armored columns from the 1st and 9th Armies executed a complex double envelopment coordinated almost entirely through radio communication. Inside the pocket, over 325,000 German troops became trapped partly because their communication systems had collapsed. American fighter bombers guided by radio-equipped forward air controllers systematically destroyed German communication infrastructure. Wehrmacht formations lost contact with headquarters and neighboring units alike. Field Marshal Walter Model's final communications before total system failure reflected the disaster: no contact with adjacent units, no communication with higher headquarters, fighting continues but coordination impossible. American radio superiority profoundly shaped the psychological reality of armored warfare. American crews fought with the reassurance that they were never truly isolated. Even when physically separated, they remained connected through invisible radio networks. German tank crews experienced the opposite: profound isolation. Unable to communicate effectively, they fought fragmented battles inside larger engagements. Otto Carius, one of Germany's most successful tank aces, described many of these difficulties in his memoir Tigers in the Mud, though he focused primarily on tactical realities rather than the communications gap itself. The strategic consequences extended far beyond individual engagements. American offensives during 1944 and 1945 maintained relentless momentum partly because radio networks allowed coordination across enormous distances. General Patton's Third Army raced across France sustained by communication systems capable of maintaining command over hundreds of miles. German commanders consistently underestimated American effectiveness because they simply could not imagine the scale of the communication advantage possessed by U.S. forces. Heinz Guderian himself, serving as Inspector General of Armored Troops, recognized the problem but lacked the means to solve it. In a December 1944 memorandum, he admitted that American coordination repeatedly neutralized German superiority in tank quality. After Germany's surrender, American technical intelligence teams inspected captured German equipment. Their conclusions confirmed battlefield observations. German tanks frequently possessed superior armor and armament, yet their communication systems were disastrously inferior. U.S. Army Technical Intelligence Report No. 176 concluded that German tank communications lagged approximately 5 years behind American technology. The absence of FM systems, inadequate radio distribution, and poor electrical suppression created fatal operational weaknesses. Soviet evaluators reached nearly identical conclusions. After examining captured German equipment, the Red Army chose to base post-war radio development on American designs rather than German systems. Production and deployment figures revealed the extraordinary scale of the American achievement. Over 50,000 SCR 508/528/538 radios were produced. Sherman tank production totaled 49,324 vehicles. Radio deployment reached 100%. Transmission power measured 25 watts. Frequency stability remained crystal controlled within plus or minus 0.01%. Effective range while moving reached 7 miles and extended to 15 miles while stationary. German figures told a very different story. Roughly 6,000 FUG-5 transceivers were manufactured for approximately 12,000 medium and heavy tanks. Full transceiver deployment reached only around 20%. Transmission power measured 10 watts. Frequency stability drifted by roughly plus or minus 1%. Moving range often fell between half a mile and 1 mile. The operational consequences were enormous. American fire missions averaged 3 to 5 minutes from identification to execution. German fire missions often required 15 to 30 minutes. American armored units maintained near total coordination. German units frequently fought blind. The communication superiority of Sherman tanks established principles that continue to govern armored warfare today. Modern main battle tanks carry advanced communication suites whose origins trace directly back to the SCR 508 concept, digital rather than analog, yet built upon the same principles of universal connectivity and reliable coordination. When West Germany rebuilt its military during the 1950s, the Bundeswehr made communications a top priority precisely because of the lessons learned during World War II. Every Leopard tank produced carried comprehensive radio systems. One Bundeswehr training manual stated directly, the defeat of technically superior German tanks by inferior American vehicles equipped with superior communications proves that information dominance outweighs platform superiority. Modern conflicts have repeatedly confirmed that lesson. During the 1991 Gulf War, coalition forces with vastly superior communications destroyed Iraqi armored units equipped with Soviet-designed tanks that were individually formidable but poorly connected. In 2003, American forces again demonstrated that network-centric warfare defeats platform-centric warfare. The story of Sherman tank radio superiority represents a triumph in the electromagnetic spectrum more decisive than any advantage in armor or firepower. German tank crews fought much of the war without fully understanding this revolution. By the time they realized every Sherman functioned not merely as a combat vehicle but as part of an integrated battlefield network, the outcome of the war had already been determined. The SCR 508 transformed the M4 Sherman from a merely adequate medium tank into one component of a far larger weapon system incorporating every American armored vehicle on the battlefield. That transformation proved more decisive than any improvement in armor thickness or gun caliber ever could. Every Sherman carried the true tools of victory not only in its 75 mm cannon or sloped armor, but inside the 181 pounds of communication equipment connecting its crew to every other American tank crew. That connection created a form of collective battlefield intelligence no isolated German tank, regardless of armor or firepower, could match. German forces learned this reality through bitter experience. At Kasserine Pass, in the mountains of Italy, across the hedgerows of France, and during Germany's final collapse, American tanks demonstrated levels of coordination that German doctrine considered impossible without visual contact. The Wehrmacht never developed an effective counter because it never fully comprehended the technological gap. Field Marshal Wilhelm Keitel's alleged remark at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," whether authentic or apocryphal, captured a profound truth. America had not simply built 49,324 Sherman tanks. It had built 49,324 interconnected nodes within the world's first armored battlefield network. What historians now call network-centric warfare effectively began in 1942 when the first Sherman equipped with an SCR-508 entered combat. From that moment onward, warfare changed permanently. The side possessing superior communication would defeat the side possessing merely superior weapons. Connected forces would triumph over isolated ones. This transformation remained largely invisible to German forces. They witnessed American tactical effectiveness without recognizing the technological foundation beneath it until far too late. By the time German commanders understood that every Sherman possessed communication capabilities unavailable to most German tanks, the war had effectively been decided. The Wehrmacht's inability to recognize and adapt to American communication superiority remains one of the greatest intelligence failures of World War II. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving its communication crisis. Instead, Germany continued constructing technically superior tanks that fought as isolated machines while American forces fielded adequate tanks that fought as unified systems. In the end, the electromagnetic signals carried through SCR-508 radios proved more decisive than the armor-piercing shells fired from German 88mm guns. The ability to coordinate, exchange information instantly, and fight as a unified force rather than disconnected vehicles ultimately determined victory more reliably than any visible superiority in armor or firepower. Sherman tank radio superiority permanently changed modern warfare, establishing a principle that still governs combat today: connection means survival, isolation means defeat. German soldiers discovered that truth across battlefields spanning 3 continents, realizing too late that the Americans possessed not only numerical strength, but overwhelming superiority in the dimension that mattered most: the ability to fight as one.